All right. So make sure my audio's working. Okay, it's good. Make sure my audio's working. I don't want to run into something here. Okay. So this picture is in your book. It's figure 29.6. It does a really nice job of showing you the hormone levels based on where you are between weeks 0 and 38. So ovulation is week 0, obviously. Now we get to implantation. You can see HCG is going to start to be secreted because the chorion is going to be developing. You can see that right now at weeks 0 through 2 for sure, the progesterone levels don't change much. Estrogen stays about the same too. But you can see now at about week, just before week 12, you can see that placenta is now the main producer of estrogen and progesterone, which is good because the corpus luteum is not going to be doing much anymore anyway. As the placenta continues to grow and develop, Callie, would you mind shutting the door in the back, and I'll get this one over here. Thank you. So as the placenta grows and develops, you can see how it's going to continue to go up, 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 up. And then right before birth, you can see how estrogen and progesterone start to go down a little bit. The placenta is aging. That timing, as the hormones start to tail off, is going to sort of be a signal to the mom's body that it's time for labor. And then labor should be coming shortly, and then birth. And then obviously, once the placenta is delivered, then the estrogen and progesterone levels are going to go way down. Notice how HCG is at its peak at about week 8. So, speaking from experience now, this is not first-hand experience, second-hand experience. But first, when we found out that we were expecting our first daughter, my wife was at about 8 weeks. She thought she was going crazy. She didn't know what the heck was wrong with her. Then we found out she was pregnant. That answered a lot of questions. She even said, "I don't know what's wrong with me." I'm like, "I don't know either, but I hope we find out soon." But anyway, she took her pregnancy test right about week 8, and it went off like a Christmas tree. I mean, because you look at the HCG levels, I mean, she checked, she was in the bathroom, and she goes, "Victor, just give it time." She goes, "No, I'm pregnant." I mean, she came with that quickly. So HCG goes up. So the pregnancy tests, if you don't know, well, I guess they have shows that are used to. Is that show still on? I didn't know I was pregnant. Is that show still on? I don't watch much TV, so I don't know. It's still on? Yeah. So anyway, most women, by the time they get to about like weeks, 22, 26, they don't have to take a pregnancy test to know they're pregnant. So I don't know. But anyway, the pregnancy tests effectiveness goes down significantly. But like I said, by that time, you're kind of noticing that your abdomen is starting to get a little bit larger. You're going to think, well, something might be going on here. You probably know you're pregnant by then. But again, they had these shows. I didn't know I was pregnant, and I'll take it for the word. They didn't know they were pregnant. So hey, that's how it was. It's how it was. I'm not going to judge. I've never been pregnant, so I don't know. So maybe I don't know. Anyway, so let's look at this now. On week 3, this picture here in the top left. Now you can see how the embryo is developing. Now, we're not focusing so much on the embryo here in this picture. It's looking a little bit different. If you notice, if you can see it very well, there's a little red line in between the blue and the yellow now. So we've sprouted new growth of something in the embryo. We'll talk about that in a little bit. But let's look at the chorion, and you can see how the syncytiotrophoblast has grown, and then the cytotrophoblast is growing, and you can see this new layer here called the chorion, which is developing. And the chorion starts to grow little finger-like projections. Whoops. The chorion starts to grow these little like finger-like projections outward. These are called chorionic villi. And these are going to start reaching out toward the blood vessels from the endometrium. And so basically the syncytiotrophoblast and the chorion together set up the precursor of what is to become the placenta. Now, you can see that in week 4, that chorionic villi is continuing to grow and develop. Now, keep in mind that this is the uterine cavity over here. I mean, so this is like the inside of the uterus. This over here, this over on this side, this is the endometrium. All right, for this picture. Okay. So you can see that the chorionic villi are establishing themselves here between the embryo and the uterine cavity. Well, that embryo is going to start to grow pretty rapidly, and it's going to really start to take up a lot more space. And so what you're going to see here is that, knowing that this is going to happen, the chorionic villi that are over here on the uterine cavity side are going to basically die away. They're going to go away. They're not necessary. They're not needed, because look at the placenta here. I mean, it's growing. I mean, this is early week 4. This is late week 4. I mean, things are happening really fast. We're setting up the network, and once you can see it, I mean, early week 4, late week 4. Look at the embryo. I mean, we're moving lightning fast here, because once we get tapped into the mom's blood supply, now we're in business. Now we're really going to see rapid development. Now, here's the thing. As the chorion develops, we start to see that inside the chorionic villi, we actually have umbilical veins and umbilical arteries that start to grow and develop. You see them here? And so this is the beginning of the umbilical cord with the umbilical vein and then the umbilical arteries. And so now we have blood vessels that run through the chorionic villi. Here's mom's blood over here. Okay? Here's the wall of the chorionic villi. So we've got a nice wall that separates the mom's endometrium from the blood vessels of the chorionic villi. So mom and embryo's blood never directly touch, never directly interact, but the membrane that separates the two is thin enough that oxygen and nutrients and wastes and other things can pass through. So this is how the baby benefits, well, I shouldn't say baby, the embryo benefits from what mom has to offer, but it never has a direct interaction with mom's blood. All right. Do we all feel comfortable so far with what we've talked about and how things are progressing? I know stuff moves fast, so I just want to make sure that we're getting it all. Okay. So let's go back a little bit and look, before we get into the embryonic period and start talking about gastrulation and the primary germ layers and all that, let's just back up a little bit and just make sure we're all on the same page. On page 3, letter D, the formation of the bilaminar germinal disc, because we're going to talk about the embryo in a little bit. So remember, we have the 2 layers, hypoblast and epiblast. Hypo means under. Epi means above, all right? So we talked about the bilaminar germinal disc and the membranes. We have the yolk sac, the amnion. We talked about the chorion. Now, the yolk sac in humans is different than the yolk sac that you see in chickens and birds and so forth because, as it says here, it does not store yolk as it does in the eggs of birds, but rather has important structures for blood cell and blood vessel development. Yes, and your gut too. So some of the structures of your body, like your blood vessels, some of the structures of your gut, some of your red bloods, your blood cells, are going to come from the yolk sac, but the yolk sac does not have the same purpose as it for us as it does for a bird, because we're not expelled from our mother's body in an enclosed egg. We continue to get nutrients from mom, so we don't need the yolk. Birds need the nutrients from something else, so they get it from the yolk. Okay, we know what the amnion is. We talked about the chorion. All right. We talked about the placenta, so we're good there. All right. One thing I want to mention here, just so you catch it, it's on the bottom of page 3, number 5, says the placenta is selectively permeable in that it allows only certain substances to pass. However, some viruses, bacteria, and other harmful substances may sometimes pass through. So the placenta does a pretty good job of protecting the embryo and the fetus, but just be aware that some things can get through. After birth, the placenta is no longer necessary. It's no longer needed, so it comes away from the wall of the uterus and then it gets expelled. All right. Now, let's talk about the embryo. So, what we're going to see here at about week 3 is that we're going to undergo the process of gastrulation. And gastrulation is an important thing that happens because it's going to start to define a head end. It's going to start to define a quote-unquote tail end. And we're also going to see the beginning of the development of the brain and the spinal cord. And we're going to set the stage for the 3 primary embryonic layers that are going to lead to all the structures that are going to make up us. So, one of the things that happens during gastrulation is that we get what's called the primitive streak occurring. And the primitive streak is like a line that's going to develop. It's going to separate the right from the left side. So on the surface of the epiblast, you're going to get the primitive streak forming. And what's going to happen is it's sort of like a crease that forms. Now, I know that the people that are watching this video, they can't see it. Maybe I can, I want to see something. Maybe I can play around with something. Let me just try something here. Let's discard that. I want to make sure everybody can see this. I'm going to go wild here and see if I can get something to work here. Let me add video capture device, add existing. Okay, well, that didn't come up. Let's cancel that. Let's why aren't you coming online here? I turned you on. You should be on. Let's just try this here. Okay, well that's on. That's working. Okay, good. Yep. Samsung Digital Presenter. Yep. You're seeing it, but I'm not getting it to work. Hold on just a second here. Okay, well. Okay, here, let's see. Why isn't it showing? Maybe it is. Let me just switch over here to my live dashboard here. No. Let me just check something here. No, it's not showing like it's supposed to. See, I try to learn all this stuff as I go, and it doesn't work. All right, let's see here. It's supposed to be. All right, well, trying to see if there's another way that I can show you. Let me try this. It will show up. Okay, good. So why isn't my present? I don't think the problem is it's this device that's not working like it should. Mode. Live. That's not what I want. I don't know why it's not capturing like I wanted to here. Nope, that's not what I want either. Well, that's a bummer. Come on now. I want this. Okay, well, you'll just have to follow along as I describe it because it's not working. Okay, so let's go back to here. I digress. I just want to make sure I want to make sure I delete that so I'm not accidentally showing something I don't want to. All right. Okay, so if you take a piece of paper, and what you do, you got the piece of paper flat. What you do is you just hold each end of the paper, and then you bring the two edges together. And as you do that, can you see how the middle of the page goes down and I form like a little groove? So what happens when the primitive streak forms is essentially that. What's going to happen is some of the cells of that top layer, the epiblast, are going to push downward, and they're going to push down a group of cells, and that group of cells is going to become a middle region. So we had two layers. So if you take the piece of paper and you push it, you're going to get a little groove down the middle. So as it pushes down those cells, this is the epiblast, as it pushes those cells down, those cells are going to start to fill out a middle layer. So initially you had the epiblast and the hypoblast. Now you're going to have 1, 2, 3 layers. The outer layer is going to become the ectoderm. The middle layer is called the mesoderm, or mesoderm, depending on how you say it. And then the inner layer is called the endoderm. So we go from how many layers to how many layers? We start off with how many layers? 2, and we go to 3. Right. 3 germ layers. That's what they're talking about right there. All right? So gastrulation occurs. We get 3 primary germ layers that form. We also get what's called the notochord. Now, don't let this term confuse you. The notochord does not become the spinal cord, okay? The notochord is a group of cells that sort of form on each side of the neural fold, and I'll talk about the neural fold in a little bit. So just be aware that the notochord does not become the spinal cord. It's not even spelled the same way. It's C-H-O-R-D. Spinal cord is C-O-R-D, okay? So we'll talk about the notochord in a little bit. Neurulation begins. That means that the nervous system starts to develop. So just like we saw the primitive streak forming, we also have where, again, the neural tube is going to start to form. So you're going to see that the top layer, that epiblast, which becomes the ectoderm, is also going to, in addition to forming the primitive streak, it's also going to form a tube like this. Do you see how I made a tube? So if you take a flat piece of paper, okay, you got a flat piece of paper, and then you again push the 2 ends together so that the middle goes down. If you keep pushing those 2 ends together, eventually you're going to get a tube beneath that piece of paper, right? You're going to close it off. So this is the neural tube that starts to form. And the neural tube at the head end is going to become what? What's the neural tube going to become at the head end? What's the head part of your nervous system? Come on, you guys got through general AAP. I know you know this. Yeah, the brain. The brain. So the head end of the neural tube becomes the brain, and then what does the rest of it become? The spinal cord. Spinal cord. Yep. So we're forming the neural tube and the beginnings of the nervous system. Neurulation begins. All right, so we got that. Okay. So now it says the 3-week embryo is flattened, disc-like, a disc-like structure. Term the embryonic disc. This flattened structure becomes a 3-dimensional structure by folding as a result of certain regions of the embryo growing faster than the others. Okay, so how do you make a 2-dimensional structure a 3-dimensional structure? You take a flat piece of paper. And then you start to roll it up, right? So I go from this to this, and then eventually I can roll it up, right? If I take a piece of paper and make it into a paper tube, is this 3-dimensional now? Yes, it is. So remember, I had the neural tube that formed, first of all. Now if I take these 2 ends and I roll them around, do you see now I have a tube within a tube? Do you see that? That's what happens. So first you form the neural tube, and then you take the wings of that neural tube and you bring them around, and then they meet at the front, and that's how you go to a 3-dimensional structure. Now, let's go back and think about this as well. When we had the embryonic disc, 1, 2, 3 layers. Okay. Remember up here, you have the amniotic cavity, right? So if the amniotic cavity sits above this, if I take this and I start to wrap it around, I'm going to carry the amniotic cavity with me. And then as I continue to wrap around and close off in the front, I bring the amniotic cavity with me. So that's how you get amniotic fluid all around this three-dimensional structure, because the amniotic cavity is going to wrap around the entire structure as this goes from a two-dimensional structure to a three-dimensional structure. Okay? So picture, like on the top of the page, top of this piece of paper, that the amniotic fluid is sitting up here, right? But if I go like this, now where's the amniotic fluid? Surrounding the entire thing. Okay? So that's how the fetus ends up surrounded by amniotic fluid, because you're wrapping the amnion around it as well. That's how we go from two-dimensional to three-dimensional. And so that's what we see here in week 4. Now we've got a three-dimensional structure, and everything is happening very fast. We have what's called cephalocaudal folding occur in the head region. And a transverse folding occurs when the right and left sides of the embryo curve and migrate toward the middle. As a result of this folding process, the ectoderm is now entirely covering the exterior of the embryo, with the endoderm confined to the internal regions. Yes. So if we have the ectoderm here, then we have the mesoderm, and then we have the endoderm. So they all get wrapped into tubes. The cephalocaudal folding also gives us this shape where the head is kind of folded down and the tail is kind of folded up. And it still kind of persists here as the baby's kind of scrunched up. But baby's pressed for room anyway, so it's going to get scrunched up anyway. Okay. So here we can see again the primitive streak forming. What's this called, this process? Someone said it. What was it? Gastrulation. Yes, gastrulation. So you go from a flat disc. How many layers do we have here? 2 layers. Gastrulation. We form the primitive streak. Push some of these cells down into this middle layer. So now we have the top layer here in purple, we have a middle layer in pinkish red, and then we have the bottom layer, which is yellow. And here are the 3 germ layers: ectoderm, mesoderm, endoderm. There they are. In the middle of the mesoderm, we have the notochord. So here we can see the cephalocaudal folding. We have the ectoderm, the mesoderm, and the endoderm. And now you can see that we start to fold in. So we form the head end and the tail end. The mouth will be over here and the anus will be here. Notice I kind of covered it up, but what does it say? Heart tube. So the heart's starting to develop already in week 4. By late week 4, we've got a heart. How about that? Okay. We also see the transverse folding. This is the folding I was talking about before with the piece of paper, where you take the piece of paper and you wrap it around. So here's the neural tube developing, and then you take those 2 ends and you bring them together. And as you do that, you bring the amniotic cavity along with it. Eventually, you pinch off the yolk sac, so now you're left with endoderm here. You've got the mesoderm here in the middle. Got the neural tube here, and then you've got the ectoderm here, and you got everything surrounded by amniotic fluid and the amniotic cavity. Is anybody looking at this and is like totally confused or lost? Because if you are, this is when you want to mention it so I can go through it with you. Yes. Yeah, so if you're looking at this side, you're actually looking at it from the side. So it's like if I were to roll up this tube of paper, okay, and then this is the head end, this is the tail end, you're looking at it like this. This picture here, you're looking at a cross section. So instead of looking at it like this, you're looking at it like this. So you got it now? Okay. Yeah, that's the part that's tough because you're looking at two different orientations. Did everybody get that? So the picture on the left, you're looking at it from the side. Head end is over here, tail end is over here. Okay? But then when you look at here, this is like a drinking straw and you're cutting it off right in the middle, see? So you're looking at the tube from the head end, but you're lopping it off, so you're looking at a cross section through it. Okay? Thanks for asking for clarification. Is anybody else having a difficult time with any of this? And it's a lot of information, but you're at least keeping up and you're understanding what I'm saying? What happens to the yolk sac once it's cut off? Great question. It will remain in the area, but it just doesn't. It's right now it's really small. And this embryo is going to get bigger and bigger and bigger. So it's there, but it sort of becomes just kind of like an afterthought somewhere in the amnion, and then it'll eventually just dissolve and disintegrate because it doesn't have any. I mean, you have to remember this is really small. I mean, at week 4, I don't know, are we at like a ½ inch or something like that? This whole embryonic structure. So you can imagine how small the yolk sac is. Maybe the size of a pea, maybe. So it's really small here. So nothing much comes out of it. It's just kind of discarded. Okay. This is a really cool picture because it shows you what these primary germ layers become. So this might be something that you want to refer back to. Now, if you think about us, okay? We've got a neural tube. We've got a brain and a spinal cord. That's part of the ectoderm, part of that outer layer. But now, if I were to walk into a room and the room is really hot or the room is really cold, how do I determine that the room is hot or cold? How am I knowing this? What's that? It's not a hard question. Yeah. I have sensory structures built into what? My skin. Right. So you can see that I have an outer shell to my body. The outer shell, which is made up of my skin. Right? Okay. So the ectoderm. Oh, I'm on the wrong screen. I got to come over here. My skin is going to be made from the ectoderm. Also, my nervous system structures, we know that, right? My sense organs, all that. And some other structures might surprise us. The pituitary gland, the outer part of the adrenal gland, the enamel of our teeth, the lens of the eye. Those all come from the ectoderm, the outer layer. But then we also have like a middle layer that's in between the ectoderm, or I should say the outer structures, and the inner structures. So we have, let's go to the inner structure. So we have an inner part of our body, and that comes from the endoderm. So like the lining of our respiratory tract, our gastrointestinal tract, our reproductive tracts, our liver, gallbladder, pancreas, some of our tonsils, the thyroid gland, parathyroid gland, thymus, they all form like the inner area of our body. This is like the inside of our body, right? Deep within. So we have the outside, we have the inside, and then we have something that's in between both of them, the middle layer, which is made up from the mesoderm. So the dermis of our skin, our blood vessels, our muscles, our bones, our adrenal cortex, the heart, the kidneys, the ureters, you name it. So remember, we have like an outer, middle, and inner layering of our body, and that comes from the ectoderm, mesoderm, and endoderm. So as we continue to develop, those layers will eventually become these structures. So if you look at page 4, it says that the ectoderm differentiates to form several later structures. They're listed there under number 4. Number 5 talks about the mesoderm. We have a little bit about the notochord. The notochord serves as the basis for the central body axis and the axial skeleton and induces the formation of the neural tube. But remember, it does not become the spinal cord. On the sides of the neural tube, we have these chunks of material that develop. They call them somites. And then those will differentiate into like the skeleton, our muscle, cartilage, dermis, connective tissues, as it says there. We also have some other mesoderm called the intermediate mesoderm, which is the kidneys, ureters, and reproductive system. Now, I'm not going to ask you to be that detailed with it. I'm just showing you what the notes say. Then we have the lateral plate mesoderm, and that differentiates into other things. So just so you understand that the mesoderm differentiates within itself and becomes other structures. But that's beyond what we need to know here. And then the endoderm becomes the inner linings of the gastrointestinal tract and all that stuff. Okay. So here we see that cross section again through the two-dimensional, soon-to-be three-dimensional structure. So here we see the neural tube. We've got some originators of the neural crest cells. Those will eventually become like the spinal nerves, for example. Here's the notochord that we talked about. But here are the somites that I was talking about. So the mesoderm is going to differentiate into different chunks. So we have the paraxial mesoderm, we have the intermediate mesoderm, and we even have some mesoderm way out here on the ends called the lateral plate mesoderm. So that's what they're talking about in the notes and what they become. So just so you're kind of aware of that from a visual standpoint. Okay. So looking at the top of page 5, letter C, organogenesis, it says, by week 8 of development, the upper and lower limbs have attained their adult shapes and rudimentary forms of most organs have developed, although most organs have formed during the embryonic period. The peak development for organs is at different time periods. And, you know, some books I've used have given, does your book have any guide to like what organs develop by what time? Some books do and some don't. I'm not familiar enough with this book yet. Does it give you any sort of table or anything that tells you what organs develop by what time? It's not a huge point. I'm just wondering if they do. Some do. Some don't. Here's the thing. This is what they're trying to get at here. And this is like what I want you to walk away with a big picture understanding. Because some of you are going to be walking into a setting where you're dealing with women who are expecting and so forth, or they're thinking about having a child and all that stuff. And not that you have a huge say in their lifestyle choices or what they do, but for you, there are some young people in this room that maybe are thinking about having children, or have children and are going to have more, or whatever, or you know somebody. By the time when does a woman realize that she's pregnant? If she's not really trying, she's like, if it happens, it happens. If it doesn't, it doesn't. She's not really watching it closely. When does a woman start to realize that she might be pregnant? What week? 6-ish. Yeah, if she's really on top of it, right? So there are a lot of things that happen between the time that a woman conceives and actually realizes she's pregnant. And that's what the book is trying to tell you. And that's what all the anatomy books try to tell you. Is that by week 8, when a woman finally comes to terms with the fact that she is probably pregnant, everything's done already. Everything's there. She's got an 8-week-old embryo inside of her, soon to become a fetus, and it's got everything. The heart, the lungs, eyes, ears, nose, mouth, hands, fingers, toes, legs. Okay? So from a perspective of taking care of yourself, a woman has to be very cautious, because if she thinks that she might be pregnant or is open to the idea of becoming pregnant, what she does to her body and what she puts in her body can be potentially harmful to a developing embryo within her. Things like alcohol and tobacco and those types of things. And drugs. Not like recreational drugs. I mean like over-the-counter drugs. Recreational drugs too probably not going to be good either. But anyway, so there I was tell this it's not a personal story for me, but just it is a story of what happened years ago. When women were in the early stages of pregnancy and struggling with morning sickness, they would be given, the doctors gave them a drug called thalidomide to help deal with the morning sickness, to reduce the nausea and so forth associated with morning sickness. What they didn't realize is that at the time that the women were taking this to help with the morning sickness, that was when the limbs were developing. And this thalidomide kind of stunted the growth at that point of time in embryonic development. So these women were born with babies that had no upper or lower limbs. It was like their hands were just attached to their trunks, or their feet were attached to their trunks. They're like, football babies. And I'm not making fun of them. I'm just saying they look like it was like a torso with, flippers. I mean, that's kind of how they looked. Horrible. I mean, think about you as a mom, you're taking something just to help you feel a little bit better, and it ends up causing a lifetime deformity in your child. I mean, just horrible, horrible. So obviously they don't dish it out like that anymore. There's still a version of it, I guess, but there you are. Yeah. So anyway, what the book is trying to say is just be mindful that by the time a woman figures she's pregnant, for the most part, everything's there. So after week 8, now we enter what's called the fetal stage. So it's a fetus. Everything's there, but now it just starts to develop. So you can see here the major events that are occurring along the way here. So weeks 9 through 12, we see enlargement of the brain, and the nervous system continues to develop. The skin continues to develop. The kidneys are developing. The roof of the mouth. I mean, there's still a lot of work to be done here. But we see that the baby continues to grow and develop. By the time we get toward the end here, now the baby's just adding, or especially right at the end, the baby is adding fat to their body. Because when they're born, and we're going to discuss this next time we're together, when they're born, the nourishment that the baby gets after it's born is not designed to help it gain weight and grow. So what you'll see with babies, if any of you have had babies, you know this. When the baby's born, you weigh the baby, and then a day or two later, you weigh the baby again. The baby's going to weigh less because the baby's not really eating anything nutritious that's going to help it grow and get bigger. So it's nothing to worry about. It's just that's what happens. And as the baby starts to eat and starts to sustain itself on external food sources, then it starts getting bigger and growing and developing, and then you're off to the races. But so here's a guide to that in case you're interested in finding out more about what's happening. But that's about it. Let's see if there's anything else. No, that's it. All right. So I know we're not up against 12 o'clock like we usually are, but this is where we're going to stop today. We've had enough today, right? We've had enough to wrap your mind around. So what I'll do is I will get the Learning Plan 2 assignments out for you today. So they should be up later on today, and you should be able to start having at them. Don't forget your test for Learning Plan 1 if you haven't taken it yet. That's due by the end of the day, Friday. But for all intents and purposes, as far as what we're covering today for Learning Plan 2, we're done for today. So, what questions do you have for me? Yes, Kelly. Okay, stick around, and then I'll help you with that after class. All right? Yes. I do not know what the testing hours are, but I can show you where to find them. So when you go into Blackboard, when you're brought right into the announcements, if you scroll down to the bottom, it says to view the hours for the assessment center, please click here. And if you click here, then let's see. Today we're on Thursday, so Thursday they're open until 6 p.m. tonight. And tomorrow they're open from 9 to 3:30. Does that help? And then if you want to go to Manitowoc and you're in Manitowoc, you have you can do 5 to 7 tonight if you want. So that's where you can find it if you ever need to refer to it. Okay. What other questions do you have for me before we call it a day? Yes. Okay. All right. So the question was, they say that you can have a miscarriage because your baby has a different blood type than you do. What time does that happen? My guess is that now I'm just spouting off on what I'm thinking might be going on. There is a condition called hemolytic disease of the newborn, where I think we cover it next time, but if we don't, I'll go through it with you. So essentially, it doesn't usually happen with the first pregnancy. So it has to do with the RH blood group. Now, this is what I'm thinking is now it might be something completely different. That's this, but I'll explain the hemolytic disease of the newborn, because I think this is maybe what they're referring to or what we're talking about. But there is a blood type, or your blood type. You have the ABO blood group, AB, or O, and then you have RH. So you're either A positive or A negative, B positive, B negative. The positive and negative stands for the RH group. So if you are RH negative, but you have a baby who has RH positive blood, the worry is that if the mom's blood mixes with the baby's blood during delivery, now you expose the mom's blood to the RH positive blood from the baby, and then she develops antibodies. And then in the future, if she has another baby, those antibodies can go after the newborn. Okay. That really doesn't happen that often anymore, because they will take a blood sample of the mom, and if the mom is RH negative, they're going to give her injections along the way to prevent her body from developing those antibodies, so it's not an issue. But that's how it could happen. If there is another type of miscarriage that's occurring because of the difference in blood types, I'm not sure what's involved with that or when that happens. So I don't know. Generally, a miscarriage occurs because there's something not right with the development of the embryo or the fetus. Something's not progressing correctly, and so then it self-terminates. So. Does that help? Okay. What other questions do you have? All right. Well, thank you very much for coming today. I appreciate it. And if you need anything, just give me a holler, all right? Take care.